Have you ever stopped to think about how AWS actually keeps track of millions of users and billions of resources, all while keeping everything secure? Well, today we're going to crack that code. We're going to look at how AWS answers three really basic but critical questions. Who are you? What are you allowed to do? And maybe most importantly, how can we be absolutely sure? Let's dive in.
It really all comes down to this one fundamental challenge. In a massive cloud environment with countless services, users, and automated scripts all talking to each other at once, how does anything prove who it is? How does AWS make sure that a request to, say, delete a critical database really came from an authorized admin and not some random script? The answer, and it's a pretty elegant one, starts with a universal address. Think about it like this. For the Postal Service to get a letter to your house, it needs a unique address that nobody else on the planet has. AWS works the exact same way. Before you can manage or secure anything, it first needs a one-of-a-kind, globally unique identifier. And that unique name is the Amazon Resource Name, or ARN for short. This is, and I'm not exaggerating, the absolute bedrock of identity in AWS. It's the standardized naming system that lets a security policy in one corner of your cloud point with absolute certainty to a specific resource in another. It's the source of truth for what is this thing.
Okay, so at first glance, an ARN like this can look a bit intimidating, right? It looks like a random jumble of letters and numbers, but it's not. Once you learn how to read it, it tells you a complete story about the resource. So let's break it down, piece by piece.
Every single ARN starts with these three letters, ARN. Simple enough? This is the universal signal to any AWS service that says, hey, what you're looking at right now is a standard resource identifier. You can kind of think of it like the HTTP of AWS resources. It just sets the stage.
Next up is the partition. This basically groups AWS regions together. Now, for pretty much everyone watching this is always going to be AWS, which means the global commercial cloud we all use. But it's good to know there are others, like AWS-Gov Cloud for US government agencies, or AWS CN for regions in China. After the partition, you see the service. This tells you exactly which AWS product the resource belongs to. In this case, it's IAM for Identity and Access Management. But you'll see all sorts of things here, right? S3 for storage buckets, EC2 for virtual servers, RDS for databases. You get the idea.
All right, now we get to the region. And you might notice something interesting here. It's blank. So why is that? Well, because some AWS resources, like an IAM user, are global by nature. They don't live in any single geographic region. For a resource that is region-specific, like a server, you'd see its code here, like US-East1 for Virginia.
Next is the 12-digit account ID. This is the big one. This is the unique number that ties this resource to your specific AWS account. It's the critical boundary that separates all of your cloud stuff from every other AWS customer on the entire planet.
And finally, we have the resource identifier itself, the specific name of this thing. In this case, a user named Jane. But look at the slashes. This is super powerful because it shows you can build a whole hierarchy right into the name, organizing users or roles into paths that can mirror your company's departments, like users/marketing/Jane.
Okay, so now we know how to uniquely identify every single resource. That's the who. The next logical question is, how do we control what they can actually do? And this is where we move from addresses to rulebooks.
That rulebook in AWS is called an IAM policy. It's just a document written in a format called JSON, which is really just a simple text-based way to structure data, and it explicitly lays out permissions. You attach these policies to users, groups, or roles to give them very, very specific permissions.
Now, policies are built on statements, and every statement has an effect, which is either allow or deny. And listen up, because this is probably the single most important rule in all of AWS security. An explicit deny always wins. It doesn't matter if a user has 10 different policies allowing an action. If just one single policy says deny, access is blocked. Period. It's a fantastic safety feature.
So now that we know what policies are, let's go a little deeper and figure out how to actually read one. They might look like a bunch of code, but trust me, there's a really simple framework for understanding any policy statement you'll ever see. You can remember it with this simple acronym, PARC. That's P-A-R-C. Every policy statement is just answering 4 basic questions. Who is the principal? What action can they take? On what resource? And under what conditions? Principal, action, resource, condition. That's it. Every policy, no matter how complex,
Just boils down to those 4 things.
Okay, so here we have a real-world policy. It might look a little dense, but don't worry about it. We're just going to apply our Park framework right on top of this, and you'll see how it instantly makes sense of what's going on.
Let's start with P for principal, the who. This is the person, the application, or the service that's actually making the request. It could be a human user, a program assuming a role, whatever. And how do we identify them? With that same unique address we just learned about, the ARN. Next up is A for action, the can do what. This is the specific API call being allowed or denied, like S3/get object if you want to read a file from a bucket, or IAM create user to add a new person. And you can use wildcards too, like S3/star to grant all possible S3 actions. Then we have R for resource, the to what. This is the specific object that the action is being performed on. And this is where it all comes full circle. The policy identifies the resource, using, you guessed it, its unique ARN. This is how the rulebook points directly to the address. It all connects. All right, we know how to name things with ARNs, and we know how to set rules with policies. But how does AWS actually verify that a request is legitimate and not a forgery? This brings us to the final piece of the puzzle, the authentication process, which is kind of like a secret digital handshake.
This secret handshake is officially called Signature version 4. Now the good news is, if you're using an official AWS software development kit and SDK, this all happens for you automatically. It's the easy path, and it's what you should be using. But under the hood, the SDK is performing this complex cryptographic dance for every single API call to prove it's authentic.
So why all this complexity? Why is this so important? Well, this signature gives you 3 incredible layers of protection. First, it verifies identity, proving the request came from you. Second, it protects data integrity, making sure the request wasn't messed with on its way to AWS. And third, it prevents replay attacks, because each signature is only valid for a few minutes. It's complete security wrapper for every call.
So, let's put it all together. We have unique names with ARNs. We have clear rulebooks with IAM policies. And we have verified identity with Signature version 4. When you put these 3 concepts together, you really have the foundation to build secure, scalable, and well-managed applications on AWS.
And as you start building, it's helpful to know that AWS has some built-in limits or quotas to keep in mind. For instance, by default, you can only attach up to 10 managed policies to a single user. Now, these aren't just arbitrary numbers meant to annoy you. They're actually designed to nudge you towards best practices, like using groups and roles instead of just piling policies onto individual users. It helps keep your security clean. And there you have it. Unique addresses with ARNs, clear rules with IAM policies, and a secure handshake for every single request. You now understand the fundamental language of AWS security. And the real power here isn't just knowing the terms, but seeing how these pieces fit together to create a secure foundation for anything you can imagine. So the only question left is, what will you build?